Alrighty, let's see what we got. It's going to be a medium that I previously solved. Count unguarded cells in the grid. You're given two integers m and n representing the size of a grid. You're given two integer arrays, 2D arrays, where guards and walls, where guards I is rows and columns I, rows sub I, columns at I, and walls at j is rows of j, columns of j, representing the positions of the ith guard and the jth wall. Okay, positions of guards and positions of walls. A guard can see in every direction. It's cardinal, starting from the position unless obstructed by a wall or another guard. A cell is guarded if there's at least one guard that can see it. Return the number of unoccupied cells that are not guarded. Okay. Okay, so a guard gets blocked by walls. It doesn't make sense to consider guards blocking other guards because like it just continues on, right? Unoccupied. How big is this? It is pretty darn big. Okay. So if I iterate over every position, if I see a guard, then the next wall within that row blocks it. I mean, what is the worst? So the guard in this position blocks both the stuff before and after it. So if I iterate over all my guards, I think that's too slow. That's too slow if I iterate over all my guards. Well, a guard searches. Maybe it's not too slow. Maybe if I had a search. Yeah, let me think about this. What's going on here? What is going on here? So if I had something where I kept a bag or a stack of positions to search through, process the stack one at a time. Each time I process a position, I look at the surrounding positions and add to the stack any of the surrounding positions that hasn't been seen yet. That doesn't quite work. Iterate over the positions. So for each guard, what if I just did a for loop? 4 for loops. Iterating to the bars. Iterating as far as I can in each direction. seems like it'd be pretty darn slow. Wall, 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 guard. So the guard gets blocked. A guard's vision extends to the next wall, either to the left or right of it. For each position, I have a for loop. I guess for each position, if the next, let's say I'm at this position, if the first thing I see in any of the 4 directions from this position is a guard, then it is not that it's observed. So I iterate over the positions and somehow gosh. Iterate over the position, somehow detect the first thing to the left of it, right of it, left, right, north, south of it. Is that? I don't know. Not sure how you do that actually. How do you tell? Let's say you're at position in a row. How do you tell that the first thing that you're going to encounter, the next thing that you encounter in that row will be a guard or a wall? Guard. M and M. I guess those. I'm just gonna relabel this. Rows and columns. So if I iterate over every position, but if I just think about a single row, a row has guards and walls in some fashion, and then at a particular position, I can say the next thing in this row is guard or wall. I guess there's like an implied wall at the very ends. Position is only unobserved if both sides of it is walls. Both sides of that position are walls. Otherwise, there's going to be a guard. Okay. Um, let's say do row objects, make this a list, and this will track the position of every guard, and I guess this might be a 2D array. For every row, which is an index here, it's going to keep a list. Yeah, so for every row in rows, in the range of rows, and for every column in the range of calls, I need to have an empty list here. If the guard says a list of row and columns, oh shucks. Actually, that might make it easier. For every guard, I guess this would be G row, G column for the position of the guard. In guards, I'll say the row objects. Row, I don't like this objects. Row items of the row is going to append. Maybe this should be a default dictionary. Or should just be a list times times the number of lists times the number of rows. I think that might be right. Append. I'll use a tuple that is like guard. I guess I'll use a 0 for guards, and the column and 0 for guards. Actually, maybe I should define it. Actually, don't use constants very often. Guards equals guard and wall. Let's say it's 0 and 1. And I guess I'll probably need at some point a corresponding column items is going to be a bunch of column lists and maybe column items of the guard column appends guard at a particular row. Let's go and print that out to make sure it works okay-ish. I really don't remember how I might have done this before. Out of range. Oh, yeah. Number of rows, number of columns. Wait, why is it out of range? I don't think I can do this actually. Okay. 4K in range of rows. 4K in range of columns. Okay, I guess maybe I should use underscore. Okay, so the row items Okay, so the first row has a guard at 0, 0. The second row has a guard at 1 and 3, and there's no guards in the third row. Is that right? Oh no, I just read it wrong. Yeah, first row, second row, third row, and there's no fourth row guards. No guards in the fourth row. And let's just go ahead and print out column items, just check. So there should be something in the first, second, and fourth columns. Nothing in third column. Okay. Alright, so secondarily, for every wall row, wall column, and walls, row items, yeah, wall row appends at a tuple wall column wall column items at the walls column appends tuple that is the walls row. I'm pretty sure I need to sort here for every row in rows in range of rows. Row items of that row sort. Call items of the column sort. So row 0 has two things, a guard and a wall. Row 1 has another wall, another guard, another wall, and row index 2 is going to have a wall and then a guard. Okay, so that looks fine. Now the question is if this is going to get me anywhere. I mean, I guess I could. Yeah, I don't know if this I don't know if this is very fast. Answer equals 0. Guess it's going to be something like for every index. Actually, I guess it'd be for every row and range of rows. For every column index in the range of columns. So if you're dealing with a position at row, actually I think I want to do one extra bit, and that's going to be appending a dummy item to each row that is a wall at the very end. So I think this should be append. The tuple will be the number columns. The index of the extra wall here. So there's 6 columns. The index of that thing should be 6. Yeah, so number columns. Add a wall there. And similarly, if I have column items, add a dummy row at the end that is going to be a wall. Okay, so for every position, if the next element at this position, I guess maybe I should be keeping track of the index. Ooh. So I'm going to iterate through every position. So I need to keep track of, what do I need to keep track of? Somehow I need to know from a particular position what the previous, oh gosh. Oof. What the previous thing is. How many guards are there? There can be as many guards as there are positions. Okay. Yeah, I think I want to do this once. So for every position, so if I'm at this position, you quickly determine how far it can go. So if I kept track of the position, I kept track an index into the row items of the next row, of where this is, I guess, maybe. I am at row items. Keep track of like an index where this position is between the next two. Yeah, okay. I guess actually, oh wow. Okay, I see. It's the size of this thing is actually 10 to the 5th. Oh, okay. The size of the overall thing is 10 to the 5th. So in theory, you can make a 2D matrix to contain this information. Don't think they give you a grid. Okay. I'll say this is a Boolean grid for if some spot is seen. So this is going to be false times the number of columns for every row. Okay. Just go and make sure that works. So that did not work. Should give me a 4x6. I think this should be maybe that. Yeah, 4 rows, 6 columns. Yep. Okay. I wonder if that was why it didn't work before another one. I need to have brackets around list. Okay, anyways. So it's false, and then I turn on to true if there's a guard. So for every row, and you keep track of the index, the particular index this is going to be in. So I think the index is, let's say, spot index is 0, or let's say item index. And initially, the position is going to be between the first item in the row, which might be a wall, and like the previous item, which is going to be another wall. Python has a looping. I can index like -1 from item index to get the backside wall because of how Python uses negative indices. So for every column, if this position's next spot is a guard in that direction, I guess maybe so if there's a guard there, then it's seen. Okay, so if row items of this row at this item index, I guess I just call it item. One might even abbreviate to I. This item is so this item, it's the type of it is a guard, or the row items of this row, this item of the previous item is also a guard, then this position is spotted. So grid at row column is true. I think okay. And I think if this thing is, I guess if this position is actually a wall, then I need to, if this position is actually the same position, then I need to increment the item in this index. If row items of this row of this item, if that value is equal to this column, item increments. Doesn't seem very efficient, but it is what it is. Let's see if it works in, we need to do the other version of this for the up down rather than across. So for every column and range of columns, item index is 0 for every row in that column. If column items for this column at this item index is a guard, or the previous column items is a guard, then grid at this row column is true. If this is on that same spot as the item, then increment the item index. I guess, yeah, item, yeah, that should be fine. There's a dummy item, so even if item is 0, it should be fine. And then I need to go through every row and column again. Incrementing the index answer if there's something there. This might work, but I think it's also pretty slow. Did I return earlier? Nope. Oh boy. Okay. Guess maybe I need to see what's going on here. So the answer should be 7, but it's actually turning 18. One, two, three, four, five. I think maybe I'm returning the wrong thing. This should be true, maybe. Nope. 6, 7, 1, 4. Okay. Okay. What's going on here? This one's a 3 by 3. Huh. This one's a 3 by 3. So initially everything is not seen, right? Everything's not seen. Somehow true. The only thing that was seen was in the middle. Okay, I see. Technically, if it is a wall, if it's a wall itself, then I need to make this to be not seen. So if it's an item on the spot, if the row items equals column, let's see, if it matches exactly, okay. I need to say something like if the item itself is, if the row items itself is a guard, no, it's a wall. Then I need to mark this as not being able to be seen, not being able to be part of the answer. And this thing was originally correct, being false. Okay, so that solved the second case. So the first case, so it should have 7. So the first row, 1, 2, 3. Can I adjust this properly? Okay, I guess that's the best it can go. 7. So 1, 2, 3, and then these 2 in the second row, 4 in the third row. we got the first row correctly, but then the second row got incorrectly. One, two, three. Do. 1, 2, 3. Add 2 in the second row. How did that work out? So we got here. Ooh. Especially everything's not seen, and then it should have made these things be seen. So it should have set these things to be true. So there should have been false, false, false. Wait, what's the default state actually? The default state is the grid is false if it's not seen. Toggle on to be true if it's seen. Do. True, true, false, true, false, false. Okay. That's correct. Seen, seen. This should be true. That should be true based on. This should be true, 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 and there should only be one false. So row items, either the current item is a guard or the last item is a guard, then turn this position to be watched. So say row items, this row print, and then print the post. So I think I want grid at this row. I wonder if I need to have more information than that. It doesn't seem right. Row items of the first row. 0, 0, 1, 1. Okay, yeah, actually this is just a dummy wall, that's right. And then second row. So this is the guard wall. So it should increment it to 1 here. So yeah, this should be true, 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 true. Should be 5 trues and false. Okay, iterate through the logic here. Row items can be 0. The the type is guard. So this is the next item in this row. If that next item is a guard, or if the previous item is a guard, set it to true. And then if you're at the breakpoint, then increment. If you're at the breakpoint and it's a wall, then also set this to be true. Um, 0, 1. So it should change this thing to be item index 2 when it gets to the column. Okay. So okay. Yeah, it just should print out just the column like 1, 1 and 4. That's right. I'm missing something very simple about this logic. So it changes the item. Item becomes index 1. Index 1. So, oh my god, I'm so fucking stupid. I need to actually use the tuple. Oh my god. I assumed that would have given me some sort of logic error. But I assumed incorrectly. Okay. There's still something that I'm printing out here. And there is, or is that just the test result? No, I'm printing out stuff. Oh, there it is. Okay. Yeah, definitely very slow. Oh gosh. I don't know. I don't know what is the improvement here. This process is just very, very bad, I think. So, I mean, over my guards. I mean, I guess I could sort my guards and sort my walls rather than trying to create this row item stuff. Would that be any use? I mean, it would save me on trying to create a bunch of new tuples. Any given position. iterate over the rows. I'd start with a I start with the position of every guard and iterate in each direction from that position. Somehow stopping at whatever stops it up in that direction. Maybe that's better. What's the worst that could be? That could be pretty bad if that could be pretty bad if there's like a guard set over here and a guard set over here. I have to like go both ways. To go both ways. Alright, today's just not my finest day. I'll have to iterate over guards for each of the four directions. Advance the current tile and mark the tile. When should you stop advancing? When should you stop advancing? You stop advancing when there's a guard hit or a wall hit, maybe? Seems a little redundant because then you'd be walking over every tile twice, possibly. You'd be walking over stuff that you've previously seen. Iterate over the guards, and for each of the four directions, advance the current tile. Okay, well, if I wanted to try this other version, I guess maybe it doesn't require sorting at least. So if I have a grid that is false times the number of columns for every row, and then for guard row, guard column, still need to know where the walls are. I guess I could maybe create a set of the walls. Walls are gonna be could make a set of walls. Yeah, I don't think I can actually do that. I need to convert each item to a tuple. So I need to probably make a set for every wall row wall column in walls wall set dot add the top of those wall row wall column. So I might need to do that for the guards as well. No, wrong. I probably just need to set it in the actual array in the matrix. For every wall row wall column in walls, I'll say grid maybe this should be like maybe -1 and 0 for that grid at wall row wall column is equal to, let's say, 1. Everything guards grid at guard row guard column is equal to 2, and then iterate over the positions of the guards again. Let's say for each of the 4 directions, so delta, the directions are going to be change the row or change the column. Something like that. And then for every dr, dc, and deltas, while I guess this should be nrnc is equal to g row, g column, g row plus gr plus dr, g column plus d column if define is valid, rc return true if 0 is less than or equal to r less than rows and 0 less than or equal to c less than columns. If this is a valid position and it's not a wall or column, grid at nr and c equals to 0. How am I going to change this? Actually, I might make it -1 if what's there is greater than or equal to is less than 1. Then grid at nr and c is equal to -1. So -1 is the scene state. It should be a while loop. So for every direction, while nr and c is equal to that. Yeah, and then I need nr and c is equal to another version of this. So this is iterating in that same direction until it hits until it hits a 1 or 2, which is a guard or wall. Yeah, and then after it does that for everything, then I can do answer equals 0 for every row in range rows, for every column in range columns. I think the answer should equal 1 at that position if grid at this row and column is equal to 0. Answer increments. Variable. No, this should be rows. Alright, and what infinite in the while loop? While it's valid. How did this go infinite? For every direction, find the new placement. Oh, fuck. This should be nr plus dr and c plus dc. Huh. Well, that's considerably faster than before. Wonder if I can make a dummy wall to prevent having to do this loop thing, or just having to do the is valid check. Yeah, so for every So if I create a dummy wall at the end of every spot, at the end of every row and column, it should be so for every row, grid appends, grid at this row, append a dummy wall, and then I append a dummy row at the very end. Grid append 1 times the number of columns. Or maybe it should be extends. I think appends. I think that's right. Let me double check here. Non-matching. 1. Oh, yeah. So 4 by 6, there should be 5 by 7. 5 by 7, that doesn't look right. Still is 1, 2, 3, 4. No, there's 5 by 7. There's actually 6. It should be wrong. Does it matter? Guess it doesn't matter that the last row, the dummy row doesn't have the 7th column. That's fine. Okay, so that's fine. So at that point, I think I can not, I don't think I need the is valid check because it will eventually hit a wall. iterating through each direction. Whoops, what am I doing here? If grid while grid at NR and C is less than 1. Instances of list and int. Okay, I somehow screwed up. Somehow screwed up the thing again. Okay, yeah, there's too many brackets here. I think maybe I didn't need the brackets around the last thing here. Grid appends. I think this might recreate a list. Okay, so that got rid of is valid checks at least. Let's see if how much that improves or if that improves anything at all. Huh. Okay, interesting. Well, I don't know. Obviously, at some point, I kind of randomly considered this as a way to do it, but I didn't think it would be that fast compared to other ways. I don't know. So let's go and delete this and clean up things here. I'll say probably do need to have constants for these, maybe. Let's say 0 equals unseen default, -1 equals watched, 1 equals wall, 2 equals guard in the grid. So this adds a dummy wall around the grid, prevent need for check out of bounds when I iterate over the positions. I guess I should probably just use wall here. And then this is, I guess maybe this should probably be after the initial setup, really, logically. Into grid here. Actually, maybe I should. Whatever. I guess this is just less than wall. This is the directions. This is go in that direction until wall or guard is hit. And RNC. This seems a little bad that this thing is like this. It feels like this might be a do while loop, maybe. This way of iterating over NRNC. Yeah. I guess this is the initialization of it, and then this is the actual incrementing of it. I guess that's fine. Yeah, and then I guess there should be just answer if it equals 0, which means if it equals, I guess that means it's unseen. Maybe I should have had constants for that. Okay, whatever. Alright, summary. Tried a couple of approaches, but the kind of simplest one, which ended up being the fastest one, is basically create a grid of pools sized to the number of rows and columns. Set each to be unwatched. I set that to be 0. Add in guards and walls into the grid. And the guards were, for me, 2 and the walls were 1. Optional, add dummy wall to outside of grid, which was like an extra column slash row of 1s at the very ends to prevent out of bounds. Iterate over guard positions, and for each go through use a while loop that will move that position to the next position in that direction that is a guard or wall, setting each grid value to be watched. No, I made that be -1. And then last but not least, iterate over all positions of grid and count the number of watched positions. And in general, it's just iterating over the 4 positions is you have a certain delta direction, which is the change in row and column, and you change your current position by that, or you keep track of a new position based on that. Time complexity, this can be O of mn, I think, where m by n is the grid size. In general, this is a very rough estimate. Guards can be stationed everywhere, and guards will have a cost of looking for the next guard in that row slash column in either direction, and overall the number of iterations should be capped to the number of positions between guards, which is capped by the size of the matrix, size of the grid. Space complexity, this is going to be O of mn, as there is a 2D array to map the current state of the board.